not a continuous muscle. Okay, the thing that gives you these little independent bulges along your belly is the fact that there's a little bit of muscle here, and then a bit of connective tissue, a little short area, a bit of connective tissue, a little short area, a bit of connective tissue, a little bulge. And obviously when you build this bulges, this doesn't bulge, this bulges, this doesn't bulge, this does. That's how you get that roughened, tough, roughened belly. Okay, so these are the muscles. There's three on the side, okay, going in different directions, and this rectus abdominis running up the midline, one on each side. Now, the relationship between these side muscles and rectus abdominis is not consistent from its lower part to its upper part. So, way down here in the lower area, the tendons of external oblique, internal oblique, and transverse abdominis all join together so that this white connective tissue that covers rectus abdominis down here is made up of all three of these aponeurotic tendons that are coming and joining at the midline. So rectus abdominis lies posterior to the tendons of insertion of the three muscles on the side. Towards the middle area up here, around the belly button, external oblique is consistent. It stays in front of rectus abdominis. Transversus says, I've had enough of this, and it says, but I got to get back deep, and it goes deep to rectus abdominis. And internal oblique can't decide, so it comes in splits, and part goes superior and part goes inferior. And then once you get up here, the only muscle that's available is the external oblique, and it stays in front. So the upshot of all this is that from about here up, the rectus abdominis is enclosed in a fibrous sheath, right, made up of the tendons of these muscles on the side. But down low, all the tendons are running in front. It's lying right on top of that transversalis fascia, and then the peritoneal cavity and below. So you'll be asked to sort of identify. The place where the rectus abdominis really doesn't have a large back wall, and it changes to this position, is referred to as the arcuate line. So here's the area above the arcuate line, so rectus is wrapped up in these two layers. Below the arcuate line, all these tendons are going in front of rectus abdominis, so you've just got that little bitty transversalis fascia, and then the peritoneum, which is lining the abdominal and pelvic cavities down there. It's pretty easy to identify once you open up the abdominal cavity and sort of flip the walls back. Here's what you see. So here's rectus abdominis coming up, just that thin transversalis fascia and peritoneum in front of it, so you can see the muscle. And then suddenly, when it's enclosed in this sheath all the rest of the way up, there's a tough sheath both posteriorly and anteriorly. So rectus is tightly enclosed. You have to cut open that from the front to find it, but from the back it's exposed down there. So look for that when you open up or try to find it when you're dissecting, but then tomorrow when you open it up, you'll see stuff. Okay, the importance of this, one other structure you want to be aware of is, remember earlier we had the internal thoracic arteries and veins lying on the anterior wall, the posterior part of the anterior wall of the abdomen. Internal thoracic came down, the veins and arteries. Internal thoracic came down, and then they split into something called the musculophrenic, which went out here to the diaphragm, and then the continuation was something called the superior epigastric. Okay, so the superior epigastric is lying behind rectus abdominis. Coming down here, okay, out of the pelvic region, is another little artery known as the inferior epigastric artery and vein. And they're traveling upwards, again, behind rectus abdominis. Superior epigastric has an anastomosis with inferior epigastric, so that blood can travel from either up on the inside of the thorax down to the pelvis, or from the pelvis up to the thorax. This is important because if for some reason there's blockage of arteries and veins in the abdomen, there's another way for blood to get back to the heart. And otherwise, for example, if there's some blockage in the aorta, or in the descending aorta, and blood has trouble getting down here, there's another way for blood to get down on a more superficial level. So if something's wrong in the circulatory system on the inside, it's likely to show up with big blood vessels on the anterior surface. And when we talk about abdominal organs, we'll talk about some situations where this is the case. Okay, now the other issue that we've talked about and I've been alluding to is this hole, or this series of holes on the anterior abdominal wall, through which the spermatic cord, or its predecessor, the round ligament, travels from inside the abdominopelvic cavity outside. In the male, the spermatic cord going into the scrotum. In females, the round ligament going into the labia majora. So that there, as I said, there is this opening, right? This is what we've seen so far is this superficial inguinal ring. Well, it turns out, of course, that, as you know, this is just the most exterior of a whole series of layers. So for these structures to get from inside the abdominopelvic cavity to the outside, either the scrotum or the labia majora, they have to pass through the different layers of the anterior abdominal wall. Okay, so this hole, as I said, is referred to as the canal, or the pathway that structures travel in from within the abdominal cavity to outside of the abdominal cavity, basically outside of the anterior abdominal wall, is referred to as the inguinal canal. And so for the structures to go from inside the abdominopelvic cavity to outside, they pass through these layers that we've been documenting for the last 15 or 20 minutes. So the first thing they have to pass through is that deep layer, that transversalis fascia. And the hole that they pass through to get through the transversalis fascia is referred to as the deep inguinal ring. Okay? And then, as they come through the superficial layer, there's that opening and external oblique known as the superficial inguinal ring, and they have to pass through that. The canal through which they pass has borders, right? It's not just, it's an opening, but it's about that long. So where they go through the transversalis fascia is lateral. Where they pop through the superficial ring is more medial. And as they pass through that canal, the anterior wall, not surprising, is the external oblique, because that's how they pop out. That's the most superficial part. The posterior wall, again, no surprise, is that transversalis fascia, because that's the first thing they come through. And also that tendon, where the internal oblique and the transverse abdominis muscle both join onto attach on the pubis. The roof of this canal is the overarching part of internal oblique and transversus abdominis, because they have to go under them, which are going from superficial to the ring or superficial to the ligament to behind it. And the floor is this canal is lying right on top of that inguinal ligament, that lower bent part of the external oblique fascia. So obviously, to get from deep in here to out here, the spermatic cord or the round ligament has to go through all these layers in some way or other. Okay, so let's look to see how this actually takes place. So we've gotten rid of external oblique, and we've actually gotten rid of internal oblique. So we're looking at the beginning of the canal. So these structures, again, either the spermatic cord shown here or the round ligament, they pop through this hole in the transversalis fascia. And that place is known as the deep inguinal ring. Okay, so it's this very thin fascial layer they pop through it. Okay, so it goes through the deep inguinal ring in the transversalis fascia. The transverse abdominis sort of arches over, but they don't have to pass through it. They just pass under the transverse abdominis. Okay, they go under this where it's arching over like that, through that conjoint tendon, so it doesn't, the structures don't pass through this muscle. They almost pass under the internal oblique, the next superficial layer, but as they pass through, they pick up some muscle fibers from the lowermost part of the internal oblique, which form, at least in the spermatic cord, which form some long longitudinal muscle fibers that are following the cord all the way down and connecting the cord and the covering of the testes up with the internal oblique, and that's known as the cremaster muscle. Internal oblique that's wrapping around the spermatic cord. And so here it is shown better. So they pass through the lower border of internal oblique, and some of the muscle fibers from internal oblique hang on and come down to surround the spermatic cord and to surround the testes. And then finally, the last of this canal, the end of this canal, is that superficial inguinal ring. And as they pass through the superficial inguinal ring, part of the fascia overlying the external oblique comes to surround the spermatic cord, and that part is known as the external spermatic fascia. So here's a cross section with no spermatic cord into it. So as the testes come down with the spermatic cord following, or the round ligament in the females, first it passes through this opening in the transversalis fascia, under transversus abdominis, through the lower layer of internal oblique, and then through the external oblique, opening and external oblique, known as the superficial inguinal ring, and then travels down like that. So they pick up a little bit of covering from the transversalis fascia, nothing from transversus abdominis, pick up a little muscular layer from internal oblique, pick up another fascial layer from external oblique. And the upshot is that the surroundings of the spermatic cord are continuous with parts of these layers of the anterior abdominal wall. This is just a schematic showing the spermatic cord has arteries and veins and obviously ductus deferens for taking sperm back up, and so forth. And likewise, the testes are covered by a series of layers, which are continuous with parts of the anterior wall. So here's a better schematic, so that the transversalis fascia on the anterior abdominal wall comes down in here where it's known as the internal spermatic fascia. Okay? Transversus abdominis just stops. It has nothing more to do with anything. Internal oblique comes down, and it's continuous with the cremaster muscle. And the external oblique is continuous with something called the external spermatic fascia. So the layers of the testes are continuous with the layers of the anterior abdominal wall. We don't ask you to dissect out testes or spermatic cord, but when you're looking at these inguinal rings, realize that they have continuing structures. Okay, here's how this all happens in development. So the testes start off way up here, very high in the abdomen, and then as the males age, they pass down through this ring and end up down here in the scrotum and dragging down these individual layers. Okay. As they pass down, what I didn't show you, the whole point of that, is as they pass down, they can also, I'll talk about in a minute, the abdominal cavity is lined by peritoneum, essentially in the same way that the lungs are, where the lungs are expanding is lined with pleura, where the heart lies is lined with pericardium. This is lined with peritoneum, and when the testes come down, they actually push out a bubble of peritoneum in front of them, and that remains down there. It should get sealed off with development so that there's sort of a bubble of a sac of what once peritoneum lying in front of the male testes, and that sac is known as the tunica vaginalis. And then here are these layers that I talked about that the scrotum that the testes pass through as they descended. Okay, why am I going on about all this? Because it's a place of considerable problem for human beings who are first of all bipedal, so there's all this abdominal stuff above your inguinal region. It's lying down there. As people get older and their abdominal muscles get weaker from not doing enough sit-ups or whatever, and then you start increasing pressure in your abdomen, you can push bits of abdomen down through this opening. This is the way stuff from inside your abdomen can get to the outside, even if you don't want it to, because there is a hole there. Okay. These hernias, which are much more common in males than females because you've had these testes to descend down there early in development, are of two kinds. The more direct path, at least that's what it's called, is you can just push through that superficial ring. You know, you've got this hole right here in the external oblique, and the contents can just sort of push through and give a bulge right there, and you know, you have bits of gut dang there. The problem is once you push a little bit of gut through a hole, it might get twisted off, it might get gangrenous and get infected and get very bad, or alternatively just means you know, you have a big bulge in the front of your lower abdomen, which is, you know, may not be terribly cute. It's more common in old age, usually from weak muscles, and it happens in both males and females. Indirect, which is called indirect, but it actually it's following the old developmental pathway. So indirect hernias, I said, you know, there's this opening through which the spermatic cord passes from intern the abdomen down into the scrotum. Well, sometimes, particularly, and obviously